Bismillahirrahmanirrahim. Let us solve this problem. For the circuit shown, determine VT, VFT, and IFT, right? So this is the circuit shown here with the 4 ohm resistance, zero point 0.2 Henry's inductance, and this source Vs is equal to 5 sine 10t, right? So let's first transform this circuit into the phasor domain. So Vs is equal to 5 sine 10t. What we can do is we can first transform this sinusoid into the standard form using the cosine function, or we can actually use this sinusoidal function in the form of sine as the base instead of first converting into the cosine form. But then we must remember that when we transform the result back into the time domain from the phasor domain, we must use the same transformation as we did for for transformation from the sinusoidal to the phasor domain. So we can use it as the base. So the sine function. So we can write Vs is equal to 5 angle 0 degrees volts here. So the phase angle is 0 here. So we are using this sine function, I'm repeating, we are using this sine function as the base here instead of the cosine, first converting into the cosine function. If we first convert into the cosine function, it will be 5 cos 10t minus 90 degrees. 5 uh, cos 10t minus 90 degrees, and the phasor form will be 5 angle minus 90 degrees, right? But instead of using 5 angle minus 90 degrees, it will be convenient to use 5 angle 0 degrees, and with sine with the base being the sine function. And omega is in this case is 10 radians per second, right? And the impedance of the inductor ZL is equal to J omega L is given by J multiplied by 10 multiplied by 0.2. So ZL is equal to J 2 ohm. So let's transform this circuit into the phasor domain. This is Vs, and that is equal to 5 angle 0 degrees volts. This 4 ohm remains 4 ohm. This is J 2 ohm, and we are interested to find V voltage here and this phasor current here. So the total impedance of this circuit is given by 4 plus J 2 ohm, and this can be converted into the polar form. This is 4 square is a 16 plus 2 square 4 20. So square root of 20 gives us 4.472 angle uh, tan inverse 2 divided by 4, that is 1 over 2, that gives us 26.565 degrees, and this is in ohms. So this is the impedance of this circuit here, and it's then convenient to find this current V now. So I is given by V S over Z, right? So this is 5 angle 0 degrees, and we have 4.472 angle 26.565 degrees. So I bar is equal to 5 divided by 4.472, and this gives us 1.118, and angle is minus 26.565 degrees amperes. So this is the current in the phasor domain, right? And we can simply transform into the time domain. IFT is given by 1.118. And now remember, we used sine as the base. So when we transform it back into the time domain, we will again use the sine form. So this will be sine 10t, right? This is the omega, right? And minus 26.565 degrees amperes. So this is our result, the current in the time domain. Now the voltage here. So voltage is given by uh, this ZL, the impedance of this inductor, multiplied by this current I here, right? So this is J2 multiplied by 1.118 angle minus 26.565 degrees. So J2 is simply equal to 2 angle 90 degrees, right? And that is 1.118 minus 26.565 degrees. So 1.118 multiplied by 2, this gives us V bar is equal to 2.236 and angle is 90 minus 26.565. So the angle is 63.435 degrees volts. So this is this voltage here in the phasor domain, and we can again find the sinusoidal function in the time domain by transforming it back. But remembering that we use the sine as the base. So this is 2.236 sine 10t plus 63.435 degrees volts. So if you see this current here lacks this voltage across this inductor by 90 degrees. This 63.435 minus that is plus 26.57 degrees will come out to be 90 degrees.